All right, today we're going to finish up with Unit 1, Lesson 2. The big idea here is we're going to talk about domain and range. In yesterday's lesson, I asked you to find the domain algebraically, which means you're going to use the two rules that I gave you. Right? You still want to keep those two rules in the back of your head, but today we're going to talk about domain and range graphically. We're going to look at a picture and determine what the domain and range is in interval notation. Okay, so that's a caveat. We're still using the same thing. So if I go on to our first definition, domain is going to be all of the values of x on which the graph will exist. Our range are all of the values of y on which the graph exists in terms of y. Sorry. You will hear me say many times when I talk about domain, how far left does the graph go, how far right, and are there any breaks in the graph left to right. For range, I'll say how far south, how far north, and are there any breaks in the graph between those two locations. So if you take a look at this first example that you have in your notes, very oversimplified, but what it does take on is the fact that if they have endpoints, they have to be clearly marked as open or closed circles. If there are no clearly marked endpoints, you should assume there are arrowheads, that they go on forever in the general direction that the graph is traveling. So if I look at this first example, this left point is negative 4, 5 from 5, 1. Finding the domain, how far left does the graph go? So how far to the left? What's my leftmost value? Negative 4, how far right? 5. However, when we report our answers, we want to be careful because negative 4 all the way to 5, 5 is a bracket, negative 4 will be a parenthesis. It's an open circle. Now, what about my range? How far south does the graph go? How far down? 1. How far up? 5. So again, this is going to start at 1 and go to 5. 1 is bracketed, 5 is parentheses. It doesn't have to do with the ordered pairs, the symbols with that. It has to do with the open or closed circles of the endpoints. Any questions? Great, fantastic. All right, you try section. In your calculator, please, graph the square root of x plus 5. Did everybody get a picture that looks like this? Okay. Whether you're familiar with the graphing calculator or not, there's a couple of things we need to start to recognize as we work with these functions. When I said to clearly indicate the end of the graphs, the calculator doesn't do that. So you're going to have to use table and a little bit of common sense combined. What I mean by that is that this is technically the end and this is an arrow. You're going to say, well, how do you know that? If you go into the table, you can clearly see that after negative 5, you have errors given in the table for your x values. It doesn't allow you to go left of -5. You also can see that as you make x bigger in the table, that y continues to grow and grow and grow. It's not an endpoint. We are asked to find the domain and range. Real quickly, do I have a denominator? Do I have a square root? Yes, so I should have a restricted domain. And it should be something similar, but I'm not calculating it by hand. I'm looking at the picture. How far left does my graph go? All the way to what? -5. How far right does it go? Infinity. So that's going to be my number set that I use. The question is the -5 bracketed or parentheses? What do you think? It's a bracket for two reasons. Number one, -5, 0 is a point in your table, which means it's a solution. It's included in the interval. Second reason is because, from what we did before, wouldn't I say greater than or equal to 0 if I were solving it? That generates a bracket. Okay? Now, what about range? How far south does this graph go? How far down? 0. How far up as this continues to grow? Nope. This is going to keep going and going and going and going. How far up does it go? Infinity. So my range is going to be between 0 and infinity. And notice I used a bracket for the 0 because it was included in the table at -5, 0. The only time you will be asked to find range is graphically. We're not going to do an algebraic calculation of range. Right? So anytime a problem asks for that, you need to have a picture or be able to generate a picture. Calculator of range. Questions? All right. God bless you. Now, vertical line test. This one is super easy. We've done this. You all seem to know what it is. Determine whether or not something is a function. Does it pass the vertical line test? First one, yes or no? No, yes, yes. Ooh, we have a mixed bag here, yes or no? Okay, well, for the sake of argument, let's draw on a vertical line at the question mark. We've got this, and then we draw in the vertical line. Okay, this is an example of a piecewise function. It has two separate pieces. At this point, it touches here. Is this technically a solution, the open circle? No. Therefore, it technically only touches the graph at one place, this closed circle. Okay, so the answer would be yes for this. So again, not a function, is a function, is a function, is a function. Questions? Awesome. Moving on. Increasing and decreasing. All right, here's what's important about this slide. Whenever you read a graph to answer the question, you always have to read left to right. If you read right to left, you'll get a different answer and it will be the wrong answer. So in all of these cases, even though the arrowheads point this way and that way, we always start on the left and read across to determine which one of these is going on. So if you notice, F is increasing because it's going uphill, decreasing downhill, constant, coming across and remaining the same. Looks like that. Okay. If it rises, if it falls, or if it stays horizontal. We're reading left to right always. Don't follow the arrowheads, read left to right. Okay, flip the page. We only have one more example. Okay, I've kind of cleaned up the graph that I have. I don't know if you want to do the same. I made this a solid dot here on the far left. Yes, it's a solid dot here. I put a solid dot here. Put one here. This was open. And then on the end of here is an arrowhead. All right, so this example is going to seem really easy to a lot of you. However, moving forward, there's a slight thing that happens in your brain. So I want you to make sure you take very good notes here and ask questions, because I'm pretty sure I'm going to catch you at some point making this mistake. Here's the issue that we have. First of all, determine the intervals. These are always going to be x intervals. They're always going to be the input values. And this is where it gets tricky. Increasing and decreasing is a change in y. So notice if I take this first orange piece between here and here, would you not tell me that's an increasing part of the graph? And you want to tell me that it increases from this y value to this y value. But we're not going to use the y's. We're thinking about y because of the change in height. We're actually going to start here and go, let's say we go right to there. Here. I want to know the x interval for which it's increasing. So for this first section of the graph, 1, 2, 3, 4, 5, 6, 7, it's going to increase from negative 7, 1, 2, 3, to negative 3. Now, these are intervals again. It is my recommendation that you always use parentheses. Wait a second. What? This is a solid circle, Mrs. Gomerty. True story. It is. However, we don't have a point on the other side of that that's relative to that point to determine if it's increasing over here or not. So because of that, most textbooks will use all parentheses. So I'm going to put that up here as a little star. Use all parentheses. Always. You can't tell on the end at that moment if it's increasing or decreasing. It's relative to the points on either side, and endpoints don't have a point on the other side. Now, the second part of the graph I'll do in red is going to start here and come down to this key green point. So now we're going to be here. So my decreasing part of the graph is from negative 3 to 1. Notice I'm using the x-axis, the x values. Then I have a constant part of the graph. 1, 2, 3, 4. So that constant goes from 1 to 4. It's 1 to 5, isn't it? And then my last section of the graph starts here at 5 and goes to infinity. Increasing from 5 to infinity. Roller coaster ride. Uphill, increasing. Downhill, decreasing, constant, increasing again. Questions on that?